Bismillah ar-Rahman ar-Rahim, students. This is a concept of composite functions and its domain and range. So let's see how we can do this kind of concept. So actually, function is just a machine. Okay, we have. So and every function, every machine has input, and every function has output. For example, this is a machine. Okay, and machine name is f of x. It gets input and it gives output. Okay, so idea is very clear, I hope so. And let's say there is another machine which take its output as its own input. Have a look here. I hope so you got the idea. So let's discuss this one by one. So this is input of the first function. This input of first function, and this function after operation will give you some output. And this output will becomes input for second function, function number 2, and then it gives us output. And this whole is called composite functions. And let's have some examples, then inshallah we'll hope so you understand. For example, let's take a function f of x is 2x plus 1, and x value is bigger than equals to 1. Another function we have x squared plus 1, and it starts from bigger than equals to 5. So you can see this one, this domain, this is called x, both are called domains. That you know already that x domain stand for domain, and y, which get a result of that domain, is called range. And domain is also called input. And range is also called output. Okay. Have an example here. If you plug in this one in the place of x, okay, you replace 1 here. So let's see what happens, what we get answer against 1. We get 3. And then I plug in the other number after 1. What is the number 2? When I plug in 2 here, 2 2s are 4 plus 1 become 5. And when I plug in 3 here, we get a 7. I hope so got it. But problem is this, what is this domain? Okay, this, first of all, this 1, 2, 3 are input and 3, 5, 7 are output. So this 3, 5, 7 output will become as an input of the second function. So this will go in second function to make it composite function. If I want to make it component function f g of x. So first of all, we will decide, is it possible to form or not? Is a such kind of machine which when we're going to make it, it is a formation is possible or not? This formation depends upon many things, but most important thing which depends upon that output of first function must eligible to be for input of the other function. For example, this function is not accepting the values less than 5. It accepting 5 and above 5. Domain is called boundary, limitation. Okay. So for example, you can have a small idea that this is a, you can say, any example we can take, like cupcake factory. So whenever cupcake factory is there, so there is a cupcake. So we put material inside or cake inside. So first of all, it must be which we cake inserting inside. must have capacity to take input. If let's say cake is big one and cupcakes, this paper capacity is smaller, it cannot go inside. I think you can understand from here. Okay, so it means this cake cannot go in this cup. All right, so this is called output of first function, and this is input for the second function. So this output must be depends upon the input of second function. So if this cake is smaller, then this cake can go inside. Okay, like adjust according to the input or according to input of the second function. Okay, and here I tell you one thing. This is called outer function, outer, and this is called inner function. Inner function is here. So it means inner functions range or output must according to the input of the inner outer function. Like if I get a such kind of output, like I get a big cake, so and it is not according to the size of the cup, so cake cannot go inside and we cannot finalize our product. So we cannot make this machine will not work. So we will not form the composite function. I hope so you got a basic concept. So this is a basic concept behind the scene. So that is why whenever this output comes, should we bust in the boundary limitation of input. For example, let's try to I get an idea. Inshallah, I believe you got a concept. Problem is these are the outputs of the inner function. Or let's take it because I took a function of f, so now I change it. I change it. Here I write g as an outer function, f of x as an inner function. I plug in these values in function and I got these ranges. These ranges are output, but problem coming what? These values are not according to input. Why? Because imagine this is a big cake and there's a cup. And cake is not inside going cup. Logic, because this is adjusting, no doubt, but this 3 is not adjusting. X values are bigger than 5, but I am getting X values bigger than 3, bigger than 3, 3, 5, 7 onwards. So according to situation, these values are not satisfying the domain. So it means what is the situation, students? I hope so. You got the idea. Whenever you want to make a function formation possibility, so what is the basic criteria? Whenever we will put input in any function, like I put domain inside function, we get output, and that output must be in the boundary of this domain. All right, it must be in the boundary. But in this particular condition, this 3 is creating trouble for us. So you can say that what is a domain? Look, I'm going to show you now. A domain of function is what? Domain of function of f of x is very clear. X is bigger than 1. When we to get the output of this one, output, it is giving us what? It is giving us y value is bigger than equals to 3. And this will become an input. This will become an input of a second function. But problem is that this is not according to situation. Our domain is bigger than 3, but what is the machine saying? Number 2, that it should be bigger than 5. So it means it is not in the range, not not in the input of the second function. So it means what we got a story simple. We got a story simple. The range of this is called range of first function. Look. This is a range of first function. It's called domain of first second function. So finally, I'm writing here the range of inner function must inside, must lies inside, must lies inside the domain of outer function, the outer function. This is a basic criteria. If it is not satisfied, we cannot make a composite. So this is a formation criteria, formation of composite function. I hope so. You got a point very, very clear. So you can see the example even, okay? So let's go reverse. Reverse means you understood that, so it means g f of x not possible. Okay, this is very clear approach. Now let's go the other way around. Other way around means let's check with the, can g can go inside f or not? So let's start. So first of all, I will plug in 5 inside function. So let's see, g of 5 is 5 to power 2 plus 1. I got 26. G of 6, because it's saying x value bigger than 5. So 6 to power 2 plus 1, I got 37. Okay, so I think understood what I'm saying. And g of 7 is coming 7 square plus 1, so 50. So what is input is this, and what is the first machine output? First machine output is this. So I can say that y values are going bigger than 26. So check it, is this lies in this or not? Check. So it is lies. How come? Because this range will become, must be in the limitation of the domain. And check it, I'm getting, if you convert it, x bigger than equal to 26. And what is this? X is bigger than 1. It means x is bigger than 1 is that. But here I'm starting for, this is for what? This is for f of x. This is for f of x. And for g of x, I'm getting what? I'm getting, this is g of x. X is bigger than equal to 26, which I got from here. So it means all this domain lies in it. You see? So all values of this, the output of the function, I mean range of function. I said that range of inner function must lie inside domain of function. Look, is this range of function of the inner function? Yes. Will become domain of inner function for second outer function? Yes. Is this lies in this in the domain of second function? Exactly correct. So we can say that as range of inner function. What is inner function here, students? G. Inner function g of x lies inside the domain of outer function f of x. So f g of x, f g of x will form. So this idea is very clear. So first of all, we decide the function is formable or not. Like when can we make a composite function or not? So sometimes function is not possible, simply say no, okay? And sometimes it's possible. So I hope so the concept is very clear. And now let's talk about the domain and range of the composite function. So in this particular condition, this one, second one, first example, not possibility, okay, that's other condition, but now possibility is there. It means I can make it. So then what is a domain? So now I'm deciding domain and range of composite function. So let's start these two functions. I'm copying and I'm pasting here. Okay, let me write. Maybe some issue is coming. Okay, let me write the functions. Fx is equals to 2x plus 1. Okay, and x squared plus 1. and domain of the upper function is bigger than 1, second is bigger than 5. Now we decided that is possible to form. Okay. Now what is a domain of composite function? So naturally, domain of the function is because what we got all values, it is coming inside. So what is means G all values, this all values inside lies. Okay. So this is called domain of composite function. And what is the range of composite function? Very interesting. So first of all, we got a domain. What? So we plug in this 5. First of all, look, I'm going to show you. I plug in 5 here. Let's start. I'm getting 26. This 26 will become domain for this function. Okay, students. So domain means this, I will plug in there. So I plug in this value there. So I got 52, 53. So base, because x is bigger than 5, is a domain of the inner function, and I got range of the inner function, which become domain of the outer function, and this is our range of the outer function. So what is the range, students? Which I'm writing it now here again. So this was my question, and now I got it finally. Is what's coming? Y value is bigger than equals to 53. So I hope so you got a point very, very clear. So this is a basic concept behind the scene. So I think now you got a whole picture. So first of all, we will put inside any x value like domain of inner function. We plug in any fun function. Okay, any function. Then we get output from here. The range will come from here, and the range of the inner function will come from here, and that will give a name of what? Domain of outer function. And then we will plug in other function, and then we'll get what? Finally, the range of outer function. So I believe the whole idea is very, very clear. So this is a whole story. Okay. And this is called in the domain of the whole composite function, and this is called range of the composite function. I hope so the concept is very clear, and let's go some examples. Yes, students, have a look here now. This example of October 15, question number 13, variant 13, and question number 8. So what a example we have here, composite. Question is, function f is defined here. This is a function f. You can see, and domain of function is given by him. So I'm writing now here, f of x is 3x plus 1, and domain is given here. And the function g is given here. I'm writing g of x is -1, negative x squared, but domain is x is less than minus 1. And find the largest value of a for which the composite function this can form. So he's not asking form or not. He said must form. Okay. So what is the situation? We have g f must form. Okay. According to plan, this is called outer function. This is called inner function. So first of all, what we'll do it, as you know, first of all, what to do, inner functions range I will find. So I'm copying the top function. You know, domain is what? Less than equal to a. When I plug in this a value here, I'll get a range of inner function. Range of f of x is what? So 3a plus 1. This is a range. Okay. This is, for example, you plug in a value and lesser, okay? So x value, we plug in a value and less that. So this is for example, y value is a 3a plus 1. So from here, this value is for example, just give an idea. So it means y value is rising up, okay? So just example, I take it, this is a straight line, I get it. So starting from here, okay? This is a rough idea, only give idea, okay? So this range will become domain. So we'll give a what? This we'll call range domain. This is called domain. So domain of outer function will become domain of outer function, which is g of x. So it means this domain must be inside this domain. All right, this is a condition I said before. So it means this should be satisfying. And what is the domain of that value? X is less than equal to -1. So this domain cannot be outside, wrong. It must be inside it. I hope so got the idea. So it must satisfy it. We can say that this domain must be equal that. So it means 3a plus 1 must equal. So they must be equal. What is less than 1? So this also less than 1, -1, sorry. So now this goes there. I get -2. And this is our answer of A. So which is the values that it make the function form, okay? That a composite function, that what is the largest value of A? So f g of x can form. I hope so got a point. And let's try some more examples. Yes, have a look at this example. This question, we have June 2016, variant 13, and the question number is 10. So this is also a good example of composite functions. So let's try to solve it. We have given two functions, you can see clearly. One function is given here, f of x, with 2x plus 3, and domain is bigger than 0. Second function is we have g of x is ax squared plus b, but x is less than equal to q, you can see. And after combining, he given us f g of x, 6x to the power 2 minus 21. This is also less than q. So I hope so this point is very clear. So now he's asking us that find AB. How to get AB? I think this is a very good help available that g of f, g of x already found. So one he found, one we will try to find. So we will combine them and then we'll compare them. So putting function f in g and f, sorry. So solution start from here, part I. So first of all, copy function of f. Then empty spaces both sides. So g function will come here and its value comes here. So ax squared plus b. Now students, this is a f g of x which is given here. So 2ax squared plus 2b plus 3. If this is a f g of x which is matching. If we compare these value with these, like what is x squared coefficient 6? What x coefficient is 2a? So we can say by 1 and 2 compare. So by comparing 1 and 2, so this 2a is equal to 6. And a becomes 3. And now this whole constant equal to negative 21. Now this 3 goes there, negative 24, and b becomes negative 12. So I hope so. You got a first part clear. This is a first part solution. He was asking that find AB. This is done for 3 marks. Now, greatest possible, now is the composite functions concept again will play a role here. He's saying greatest possible value of Q, how to get Q value. Now we will go for the same domain range concept. So if we look at carefully FG of X. So the first of all, what is the plan? We will try that one now and have a look here, students. So first of all, we will use this both functions in next page here. Okay, but make sure the value of A and B, like A and B will find what we found will replace here. A value we got 3 and B minus 12. So we got it. Now this is a part number 2 we're going to start. And what a question part number 2, students, he's saying find possible value of Q. And you know it very well. We have a composite function fg, that yeah, fg of x. What is the basic criteria, you know, students? First of all, we will plug in this is called inner function, and this is called outer function. And what I said that inner function range. What is a step by step? Let's try. So first of all, g is inner function. We will plug in this x in the place of x. So let's find. So put x value in G. So we get a range. So range of G becoming 3q square minus 12. I think got my point. If I have a 2 here, I put 2 here. If I have a 3 here, I put 3 here. If I have a q here, I put q here. This become domain range. And this range will become domain of outer function, which is f. This domain and must be, okay, what is this domain of f? Is domain of f is x starting from here and going this way. So this must be inside it. This must be inside it. Or you can say this must be bigger than 0. So it means this, I can say bigger than 0. So I'm saying here, so 3q squared minus 12 must be bigger than or equal to 0. And now divided by 3. Here I can say q plus 2 and q minus 2. And you know it very well, whenever do inequalities, we always follow this way. And is outside means this way and this way. And we have 2 answers, less than -2 and bigger than +2. Sorry, negative is here, positive is there. And bigger than +2. But look, the question is what here? There's a less than q, less than equal to q. So it means less than equal to q. So less than equal to q. We have, sorry, equal also. You see, equal. So less than equal to. So this ignore. And this is our answer. And I believe you got a point very, very clear. So he was asking what is a maximum value of q. So alhamdulillah rabbil alameen, the maximum value of q is what here? So q value is -2. So this part also over. Let's go for third part. So now he's saying, now let's say q change, and now q is value is -3. And range of f of g is target to find. Interesting question. So let's see now. Q value is -3. So I will write q is -3. Again, I will take this whole function once again. But this time, what situation we have? But he said as q value is -3. So I will erase it. I'll write here -3. So I hope so. Let's see again. I hope so clear. Q value is -3. Okay. So have a look now, students. So what a question he's asking now. So find the range of f of g. Read the question once again. Range of fg of x. fg, fg, range. Okay. So what is the solution here, students? So first of all, as usual, you know the rule. We first of all, we will plug in, where's g? Here g. We'll plug in domain inside the place of x. So it means g at -3 gives you what? 3 times 2, -3. I get 927, and 27 minus 12. I'm getting answer is it is 5, 15 coming. So this is g minus, and this is called range. This range will become domain of outer function. So this 15 will go where? Here. Okay. And first of all, check, is this inside? Yes, it is right. So now it go inside. So what is inside going there? So it means f of 15 is what? 2 times to 15 plus 3. I got 33. And this is our range. So f, so what is the range of f g of x is what? So y is bigger than equals to 33. And I hope so you got a point very, very clear now. Better than before, inshallah. And let's go. It means whenever we need a range, we will plug in the domain inside of the inner function, get the value of the y, and that y I will plug in the x. And that will give us our final answer. And let's go for the last part of question. Is asking find f inverse, find f inverse, fg inverse, fg inverse. And fg we have already 6x squared minus 21. So fg. So let's say given any name. And you know what to make x subject. 21 goes here, 6 divide, side changes. And sorry, yeah. And now take a root, so plus and minus. And interchanging, x become y and y becomes. And this is called with fg, so it is called fg inverse. So I got this answer, but thing is, we have one either plus or minus. So for that reason, we have to look upon what is a situation here. Okay. What is the basic criteria? We have to, when we talk about this one, okay, we can see even that, or what is a range? Domain of this, what domain of the composite function is actually, because we started from here, this is called domain of x. Okay, x value is domain of fg is what? Composite function is x is less than -3. You know it very well. And you know it very well when it go left side, students, graph goes left side. So we always put here minus sign. You know it, the rule is very clear. If we go right side, for example, this, and we always put plus sign here. Logic is very clear. In inverse function, x becomes y and y becomes x. So this x value is of the function will become y. And this way y always lesser, decreasing. I put negative sign. And this is a function, x goes right side. When this become y, is going increasing, so then plus here. Now we have to finalize one last part, and that is, the question is domain. Very easy, you know, domain of fg inverse. So look at here, we have a rule. For that rule, domain of fg inverse is actually range of FG function. And range of FG function, we just got it here, bigger than. So raise same value, copy, but replace Y because domain, so replace Y by X, and that's it. So I hope so you got a point. And don't forget it, please, these two rules. Domain of any inverse function, any, for example, P inverse is equals to range of P. And what is the range of inverse function? Equals to domain of P. So this, don't forget it, please. These two rules are very, very important. So inverse function domain equal to range, and range becomes domain. This is very, very clear, because whenever we interchange student, X become Y and Y become X. So that is logic behind it. So I hope so you got our concept very clear for composite domain and composite range. So Alhamdulillahi Rabbil Alameen. So pray for me. Assalamu alaikum wa rahmatullahi wa barakatuh.